Hello everyone, good morning, good afternoon, good evening based on your time zone. My name is Fairuz Mustafa and I will be the moderator and the host of ICICT 2022. Dear authors and invited guests, welcome to our first technical session, 1B. On behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Information and Communication Technology throughout Zoom. Furthermore, as you are aware, we are facing a new normal challenges while overcoming the pandemic. Hence, the conference has been shifted to hybrid mode. We are very thankful to everyone who present on this platform and to go along with digital version of the conference because of unpredictable circumstances post-COVID-19. Without you, the conference would never be productive. Also, wish you and your families that you are having a safe time and all of your families are protected again. We will enjoy 2 days digital knowledge sharing and interactive session. Also, we will have some ground rules, let's say our housekeeping before starting. The presentation will take around 10 to 12 minutes. I will raise a flag when we are reaching the limit, which is 3 minutes before the time, to make sure that you are aware if you wanted to make conclusion or focus on some points. After that, we will have 3 minutes of questions from the audience and for sure from the chair. I would request all participants who are not presenting to get muted and please take notes, make sure that you are getting most of the presentations, the publications, and the papers. Before we start, it's my pleasure also to introduce our chair for the first session. Dr. Jargis Kumar, who has received the MTech degree and computer science from DAVV Ender in 1994 and his PhD degree in computer engineering in 2008. Presently, he has working as a professor, CSE, and director of Microsoft Innovation Center in India, and he's also visiting faculty at IIT Indore MB India. In total, he has 24 years of experience in teaching and 10 years of research experience, which is a great opportunity to you to get from his knowledge and from his experience, which will be reflective to your research. He has completed his PhD under the guidance of late Dr. M. Ganwadi, and he secured many presentations and publication, which reads around 90 papers in reference to international and national journals, including IEEE, ICM conference. He also managed many well-known conferences such as WCon. Besides that, he has lots of publications. He's the chairman of IEEE MP. Also, he has a great experience in database management system. Welcome, doctor, and it's my pleasure to be the moderator with you in this session. Okay. Moving forward, we will start with our first presentation, which would be...
Hello. Sorry to interrupt, but our honorable session chair, Mr. Durgesh Kumar Mishra, is here. So welcome you. Welcome you.
Right. Thank you for inviting me for the chairing the session, and thank you, Firoz, for the nice introduction given by you. Thank you. Please start your session, please.
Yeah, thank you, doctor. Thank you for that. So yeah, we will start with the first presentation with Mr. Hoyu on behalf of the co-authors, who will present the research of titled as Magneto, an efficient deep learning method for the extraction tag summarization problem. Could you please just share your screen and start with the presentation?
I'm sorry. Can you hear me?
Yeah, I can hear you. Could you? I stopped sharing it from my side. Could you please just share your screen?
Yeah, thanks. Okay. Let me share my slide here.
Yeah, perfect. We
Okay.
can see the slides and hear you clearly. Go ahead, please.
Can you see my slide?
It's loading. Let's see.
Okay.
Okay, no, perfect. It's now shown up. Go ahead, please.
Sorry, can you? Hello?
Yeah. There is like a breaking. Could you please just go ahead? I'm sorry, looks like that there is a breaking on your side. So I think we will just shift you back to the second presentation just to save everyone's time and go to the second presentation. Would you mind? Yeah, I'm really sorry because we can't hear you. So we will just make most of the time and go to the second presenter. I'm really sorry for the short notice, but now we will introduce Mr. Kwan, who will present the paper Industrial Pumps, Anomaly Detection and Semi-Supervised Anomalous Labeling through Cascaded Clustering Approach. So could you please share your screen and go ahead with the presentation on behalf of the co-authors?
So can you hear me? Hello?
Yeah.
Yeah, we can hear you. Go ahead, please. Yeah. I will stop sharing and you can share from your side.
Okay, fine. So can you see the slides?
Yes, we can see the slides and we can hear you clearly. Go ahead with your presentation, please.
Okay. Hello, everyone. I'm Qiang Duan from ICICT Academy of Science and Technology, Shandong, China. I'm glad to share our work here. In this paper, we solved a real-world problem of industrial pumps anomaly detection. The problem comes from business units of our group. We explored various approaches and finally proposed this cascaded clustering approach. The industrial pump plays an important role in many industrial sense. They requires proper maintenance to keep normal working state and extend lifespan. In order to avoid sudden malfunction or unnecessary maintenance, the machine learning is used to for anomaly detection and predictive maintenance. The ratio of machine learning application in industrial sector was going up to 65% in 2018, which is continuously increasing. Benefit from the application of sensor and data-driven method in anomaly detection. The industrial equipment failure monitoring is more predictive instead of preventive. As to our data set, it is collected from a certain coal mine enterprise with several industrial pumps for draining cooling water underground. In this paper, the mainly used data is from the number 2 water pump. There are various sensor monitoring 13 continuously variable and 15 binary variable. Total data volume is near 900,000. And here is a abbreviation of this variable, all from the sensor. So the supervised anomaly detection approach are not suitable for most industrial anomaly detection because there are unseen faults. The the unseen faults are usually happen. For the unsupervised anomaly detection, the lack of label is a common situation. Since an anomaly is an outlier pattern that differs from expected behaviors, a simple approach is to find the data that is far away from a boundary defined by the normal data. Defined by the normal data, yes. The boundary can be obtained by clustering. The specific process is shown in this figure. We cascaded process the pump operation using two algorithms, dbScan and spectral clustering, to both identify rare anomalies and categorize common anomalies. When new data is passed to the model, dbScan can identify the fault and report to the user side if it is the first type of normal data. Then we use the spectral clustering algorithm as a supplement to deal with the second category of anomalies. Using manual identification and labeling of various types of different data that output from the spectral clustering. These data are processed and used as a training set for the further classification tasks. Therefore, we can collect and process the obtained anomaly data as the equipment continuously operating, then achieving semi-supervised anomaly state identification or anomaly data labeling by the periodical manually labeling. So when implementing the dbScan method, it requires a large amount of memory by running the whole algorithm on all variables. So in practice, dbScan is implemented to each variable independently. Performance of dbScan is highly relevant to the mean points. Performance of dbScan is highly relevant to the choice of mean points. So to guarantee the dbScan method can detect most of the malfunction points, and it is not sensitive to the normal data. Mean points is carefully selected based on the result of dbScan. The figure shows the dbScan results that are constructed by random selected 10,000 data points for each continuously variable. And the different colors represent the different clusters. In this figure, it is obvious that there are some points far away from others, and we recognize them as malfunction points. For example, the green-yellow point in phase A current, the green-yellow and green-blue point in phase A voltage, the brown point in the positive pressure, etc. So after comparing the clustering result with different parameters, the result of spectral clustering based on the 300th nearest neighbor graph is the closest to the facts. By trying the preset number of clusters to be equal to 2 through 10, the best result appears and the number of clusters was equal to 7. In this setting, the 7 clusters are separated by the spectral clustering could approximately match the 7 work state for the water pump. For example, the 0 means working and remotely controlled. Number 1 and 2 means the turned off and remote controlled, etc. Finally, the output, the conclusion is the data labeled color 3 and 5 is the malfunction data. So in the future, we will test the approach on more data set, verify its effectiveness, and generalized this approach in other anomaly detection tasks and industrial predictive maintenance scenes. So that's all. Thanks.
Thank you for the presentation and for the great job. It's over to you, Professor. Is there any question that you wanted to ask about the presentation that was?
Yeah, I have one question, Dion. This because we are having in a motor, we are having a number of parameters. That is what the performance will be based on the number of parameters. That parameters like the speed of the motors, like the how the motor is binding this, right? So how we can evaluate all these parameter in your task?
Because the parameters you said before is mostly like time series data. But in our program setting, we do the classification tasks. And the time series data can be collected by other sensors, but not showed up in our collected data. So we didn't do some works on this kind of data.
Okay.
Maybe the future.
Okay. Right. Thank you.
Okay, thanks.
Thank you, Doctor, and thank you, Kwang. All the best in your project, and I'm pretty sure that the suggestion and the question will open you future avenues for the future research. So thank you again, and now we are moving forward to the next presenter. We will listen about the great presentation about the citizen-centric as a tool of evaluating e-government website citizen centrality. The presenter will be Ms. Camelia on behalf of the co-authors. So we are all listening to you, and please share your screen and unmute yourself.
Okay, good afternoon, everybody. Can you hear me?
Yeah.
Yes, yeah, we can hear you and we can see the slides. Go ahead, all the best.
All right. Okay, thank you. My name is Dr. Kamalia Azma binti Kamarudin. I'm from University Technology Mara in Malaysia. My research is in the field of e-government, and the title of my paper is it citizen-centric? A tool for evaluating e-government website citizen-centricity. Okay, as an introduction, as you all know, e-government have shifted its focus from government-centric into citizen-centric, where it focused on citizen as the main part of e-government strategy. Understanding the requirement and expectation of citizen is the primary objective in citizen-centricity, where it views the government from outside in instead of inside out. Before we design the public service and policies, there have been many models and frameworks literatures that evaluate e-government websites using diverse approaches, but they provide limited consideration of building a practical instrument to assess e-government websites, whether they are using citizen-centric approach or not. Okay. On the other hand, Kamarudin and No have developed a citizen-centric demand model and suggested an assessment tool to be built to complement the model that they have developed as an extension of their work. So due to the above reason, this research will identify the characteristic of citizen-centric e-government websites and develop an evaluation tool to measure it. So let me explain some terms to you. Maybe you are not familiar with e-government terms that is used in this paper. So e-government is defined as government's use of ICT particularly web-based application to enhance the access to and delivery of e-government information and services to citizens, businesses, employees, and other agencies. Citizen-centric, on the other hand, means looking into government service delivery through citizens' perspective, where their needs and expectation are the primary concern. It means that we're putting citizens at the center and we design the services according to their needs and requirements. So this is vice versa from the concept of government-centric, where the services are designed according to the needs of government itself. So it is important to evaluate web-based e-government services as the public money are spent on developing it should provide return of value over time. So this is the significance of the research. So let me go straight to the methods and finding. So this study was qualitative in nature and utilized a triangulation of data collection methods of literature analysis and website evaluation. And after that, we developed the tool. Okay. So in literature analysis, as I mentioned just now, we adopted the model from Kamarudin and Noor, where they have proposed 4 components that must be available in all citizen-centric websites, which are openness. It means government provide free access to its structured and unstructured data. Transparency means government provide information about the operation and decision to the public. Participation means citizens contribute to government's planning and decision making and use government data to create better services for the community. And responsiveness means that government listens to citizen feedbacks and acknowledges it. Okay, so what we did is we collected from a database from keywords such as citizen-centric government, user-centric government, citizen-oriented government, open government, and etc. We collected all the characteristics that falls under those 4 categories. Okay, and then we use thematic analysis to group the data together. So as you can see here, these are examples of the transparency component. So the characteristic that we collected are such as social media, operation and activities information, sharing decision made, and etc. And after that, the characteristic is grouped into teams. So similar teams are grouped together using thematic analysis method. And then to complete the structure, description for each characteristic was formulated and it was derived from literature analysis process that has been carried out before. So as you can see here, this is an example of the transparency component where we have the theme here, the characteristic, and from where we got the characteristic from and the description. And then after that, we need to validate all the characteristics that we have found. So we use website observation method. So we select national portals which are on the top ranking of United Nations e-government development index and WASEDA rankings, which means that the first 5 portals that appeared in both rankings have been selected to be observed. The national portals that fulfill this criterion were United Kingdom, Australia, Korea, Singapore, and New Zealand. So these are the countries, the 5 countries which score high points in these 2 rankings. Okay, so we use a method of Boolean method to actually determine whether each characteristic were available or not on those country's website. So for example, here I'm showing the Singapore and e-government national portal where they are showing the operation and activities information in the transparency component. So if it's available in those websites, then we tick it as yes. So the characteristic is validated. And then, okay, as I mentioned here, we give a yes or no value or not applicable. Not applicable means it cannot be detected. Sometimes due to constraints such as we cannot access certain information in the website. So as you can see here, the result for characteristic in transparency component, all of the characteristic that we collected from literature gives a yes value. and only one characteristic gives a not applicable value. So this will be omitted out. Okay, so from the website validation process, this is the result. It shows that all 39 characteristics have conformance over the national portal. 9 were rejected and 9 were not applicable. So from these 39 characteristics, we designed the tool to be used to evaluate e-government website, which I'm showing. Okay, the tool is named Citizen-Centric Checklist for e-government website, or CCEW for easy reference and identification. So as you can see here, this is the tool that we developed. Okay, the tool is actually just a manual form. Okay, it will be converted into electronic format in future research. So in the tool, we have the agency name, website URL, evaluator name, evaluation dates, and all the components. For example, the openness and the characteristic, and according to the theme, the transparency and the characteristic, participation and responsiveness. So this citizen-centric checklist was designed to be a guideline for evaluators of e-government website from government or external agencies mandated to perform e-government website evaluation. The next slide shows the second and third page of CCEW, where this is a guideline for the evaluator to do the evaluation. It gives the it gives the description of the characteristic, what it means by free, what it means by timely available. So they can refer to this description before doing the evaluation. And this is the third page is on the theme description, where we explain the meaning of each theme that we are evaluating. Okay, so we use this checklist to test or to validate the Malaysian e-government websites. Previously, Malaysia e-government website was the agency who managed the evaluation, overseeing the website evaluation is called MDEC, or Malaysia Digital Economy Corporation. So back in 2005, MDEC has introduced an independent mechanism called provider-based evaluation, or PROB, with the objective to establish standardization of Malaysia e-government website. But the issue with this evaluation that they have done is that it was not does not cover citizen-centric value. Okay, so based on my research on 30 e-government website in Malaysia, these are top website in Malaysia who scored 5-star ranking in the probe evaluation that I mentioned just now. So when we re-evaluate it again using the tool that we have developed, this is the finding that we got. As you can see here, these are the name of the agency and the URL, and these are the citizen-centric conformance score. You can see that there are some have 38 over 38 score and some over 39. This is because some of the features in the tool is not relevant to the criteria or to the characteristic being evaluated. For example, funds transfer. There are some of these websites that do not handle money or fund transfer, so it is being omitted from the criterion. Okay, so as you can see here, we calculated each of the component score, openness, transparency, and we can see how they fare. So the first, for example, the Department of Chemistry in Malaysia scored 100% in citizen-centric approach. They adopted 100% of citizen-centric approach, and we rank it. Okay, as you can see here, this is the rank, and for all the websites. Okay, so what can be done with these findings? Okay, so it can help. They can help to identify what is lacking in the government website design delivery by providing a content checklist of important characteristics that should be present in e-government website. So refining e-government websites to meet citizen-centric e-government requirement will have a major impact on how service will be delivered, which will eventually encourage higher level of take-ups of e-government online services. Nevertheless, it could also improve public service delivery because successful services are built on an understanding of what the citizen needs. So with that, I end my presentation. Thank you.
Thank you. Thank you. Thank you for the presentation. It's over to you, Professor, for the question.
Yeah, Kamalia's pronunciation is right?
Yes, Kamalia, you're correct.
Kamalia, right. I have two questions from you. Because your citizen-centric e-governance you are maintaining. The first question is whether we are going to validate your website through client level or server level. First question. Whether in the client side validation or server side validation.
Oh, we are looking at the client side, which if you have seen here, I mentioned that from the previous model, this is a demand model. Demand model means that we are looking at the citizen side.
Citizen side, client side.
Client side, correct.
Okay. But you know that is a client side validation is dependent on the data which is present over the client machine. If data is not validated, then how we can perform the validation?
Data,
right?
You mean validated data as in?
Data is not validated in client side, and we are performing the validation through client.
Oh, okay. I understand what you mean. When I mean client side, I'm talking about agencies or government agency who are providing data to the citizen. The demand side, the supply side is the side of government who's evaluating, meaning the department overseeing all the government development in the country. So we are actually evaluating the client side, as I mean here. As you can see at the last slide, this one, these are the agencies. So they are collecting their own data and they are showing the data in their websites here. So they validate their own data.
Right. Okay. Last question. What's the application of your work and who will use it?
Okay, as I mentioned here, the user of this tool is the e-government evaluators, okay, from agencies that is mandated to perform e-government website evaluation. As you know, every year United Nations does e-government development index ranking. So each country, they will have their own e-government external agency that will oversee all this the evaluation. So this can be a good tool for them to self-evaluate themselves before undertaking the United Nations evaluation.
Thank you. Thanks, Kamali.
Thank you.
Thank you for the topic and research. It's really important to everyone to get more information and to get better application that will make the shifting to the governance much easier. Now we will move forward to the other presentation titled as Information and Communication Technologies and Communicational Approaches for the Dissemination, Prevention, Understanding, and Attractiveness of Cultural Heritage, presented by Dalilia on behalf of the co-authors. So it's over to you, Dalilia. All the best.
Thank you. I will share my screen.
Yeah, please.
Can you see my screen?
Yeah, we can see it and we can hear you clearly. Go ahead. All the best.
Okay. Good afternoon, everyone. My name is Dalila, and I am the main author of the article carried out within the Locus project. In recent times, more and more attention has been paid to participatory approach to culture and heritage management. Thus, accessibility becomes an important concept as accessibility of all stakeholders to a particular site is essential for cultural heritage. Public access to a place becomes crucial and a prerequisite for its recognition as a cultural heritage site. One way to ensure this accessibility is through information and communication technologies, making information easily accessible. In recent years, there has been a focus on improving the cultural tourism experience at different scales by exploring the opportunities of using information and communication technologies. All these means have dramatically changed the way cultural heritage is displayed. So the concept of digital heritage arises with the need to register and protect heritage, increase its visibility and accessibility, involve local communities, and support the impact on cross-cutting areas such as education, tourism, creative and cultural industries. The article is based on the analysis of
sorry for interrupting you, but
58
we can't see the slide. The slides are not moving. So could you please just double check that you are jumping from one screen to another, or make it full screen?
Sorry, I didn't understand.
You are not moving between the slides. We are still on the first slide.
Oh, I know. I mean introduction.
Okay, sir. Okay, sorry.
The article is based on the analysis of 58 scientific articles with the main objective of analyzing the current uses of digital and communication technologies applied to cultural heritage and their purposes, as well as analyzing the evolution of these technological forms in a 10-year period. Before moving on the research itself, it is important to highlight some digital approaches for cultural heritage collaboration. Cases such as co-production, education, digital achieving, or location-based games are studied, as ICTs and communicational approaches have encouraged these connections with society and the use
darling.
of...
Excuse me, your slide is not moving now. You are in the first slide.
The first
Yes,
slide?
we are able to see only your first page, not the other pages. Okay.
I will stop the sharing and I will share again.
Yeah, share it again and make it full screen. Press F5. It would be easier.
Probably I will stay here.
Yeah.
You can see?
Yeah.
Yeah, we can see it now. Thank you.
Okay, I will show this way. So
yeah.
I was saying cases such as co-production, education, digital archiving, or location-based games are studied as ICTs and communicational approaches have encouraged this connection with society and the use of co-collaboration in urban planning and heritage conservation. Regarding user experience, it is important to create a digital system that provides useful service and information from different sources, from text descriptions to image, videos, or enjoy multimedia stories told in real time. 3D models can be used both for documentation and control, but also for digital applications such as virtual tours, virtual tourism, digital reconstructions, or as a diagnostic, conservation, and management measures. Associated with the social media, there is the urge to get important information in the moment, and the participation in planning inspires people, leading to great involvement in both media use and connection to cultural heritage. Following this research, it should be noted that the objectives planned have to do with dissemination, preservation, help in understanding traditions, and attractiveness. In the case of attractiveness, the interactive medium, playability, and storytelling are considered. Thus, data collection was focused on the Scopus search engine with the time interval with 2011 and 2021, obtaining 58 results at the bibliographic level. All the articles were read, emphasizing the abstract. However, if this approach did not provide enough information, the article was analyzed in detail. Of the 58 results analyzed, 22 articles demonstrate information pertinent to this research. Having said this, I now present to you the results of the research. At the first glance, can see that technologies are used according to the trend of the moment. Between the years 2021 and 2019, the predominance of social media, augmented reality, object detection, and QR codes is confirmed as current technologies. The fact that all these technologies can be used via mobile phone is an important factor of their popularity. It was possible to understand that there was between 2019 and 2017 an evolution of technological through the shift from 3D representation to augmented and virtual reality. This evolution allows information to be on a device, discarding the need to handle physical objects. The fact that technologies are evolving does not make them less important or outdated. It is possible to verify the use of marketing and websites between 2019 and 2014 as tools to promote cultural heritage through the decade, and these approaches are still used today. Finally, it is possible to conclude that between the years 2015 and 2011, the concept of interactivity was the trend of the moment. Interactive apps, websites, and interactive games, for example. Regarding to divulgation, the projects tend to highlight more interesting and enjoyable views of historical sites, promote cultural heritage to make users aware of its importance, and motivate them to frequently visit cultural institutions such as museums. Promotion and enhancement of the physical objects of cultural heritage is also considered. In the case of preservation, I highlight the conservation of the memory of and information of the sites, also the preventive maintenance of historical centers from early warnings. In terms of understanding or comprehension, the promotion of knowledge stands out through the 3D reconstruction and the accessibility of knowledge, and consequently a better understanding of the cultural value and the contextualization of the cultural environments exhibit. As for attractiveness, the articles mention the attempt to make visits to historical sites more interesting and enjoyable, and it is also highlight the provision to tourists to useful, personalized, and dynamic visit routes to make the visiting experience more stimulating and interesting. Today, society tends to take advantage to technology and the use of digital technologies to engage the community and to promote and disseminate cultural heritage values, and this is increasingly being considered. This research aimed to analyze the types of ICTs applied to cultural heritage, their objectives, and how their evolution is characterized over a 10-year period. By analyzing the 22 articles, it was possible to conclude that in recent years, a variety of technology has been implemented with the aim of involving the community in cultural heritage. It should be noted that this variety is subject to trends. That is, the evolution is characterized by being based since society change over the time. Currently, social networks and augmented reality are technologies that are at the forefront, leaving aside over the time multimedia platforms, applications, and interactive sites. In terms of objectives of these technologies, dissemination stands out as the main objective of the ICTs analyzed. These technological approaches aim to publicize cultural heritage, motivating the community and stakeholders to visit those places. It is also important to note that in addition to objectives previously decided for this analysis, it was possible to verify that there are technologies with different objectives that are equally important for cultural heritage, such as raising awareness and extending the value of museums. And it is important to remember that technological initiatives restore the cultural identity of a place, bringing the community closer and facilitating the dissemination of different cultures. Consequently, it increases tourism and the social and economical unveiling of the region. This concludes my presentation. Thank you very much for your attention.
Thank you. It's over to you, Doctor, for the questions.
Yeah, there is one question, Martin, that you are using for this cultural heritage and for the dissemination, prevention, you are using the social networking, augmented reality, object detection, and QR code for that. Have you used anything for the machine learning based application to detect this?
If I use machine learning to detect this?
Yeah.
In the articles that I analyzed, they didn't talk about the machine learning, but I know the concept. However, they talk about these features individually, so they don't group with the idea of machine learning.
Okay. Then how you can prevent, maintain, and how we can get the warning for the maintenance?
Probably I'll give you an example of the museums. I think I will talk about the case in Portugal. I only know where I still very common to use tourist guides transmit information.
Okay.
And I think the places or museums or places with cultural heritage don't adapt through these technologies that are the innovation, that are they are in the recent times. So the maintenance of the cultural heritage need to through about this adapt. It means adapt to these new technologies to prevent the dissemination of cultural heritage along of the time.
Okay. Thank you, Martin.
Thank you.
Thank you. As we are missing two of our speakers, we will get back to the first presentation again with Mr. Huyu. I will help with sharing the slides, so no worries about any distraction. He will present again, as a reminder, the MENG2 and efficient deep learning method for extractive tax summarization problem. It's a really important issue that we will all listen to. So it's over to you, and I will share the slides from my side. Go ahead, it's over to you.
Okay. Hi, everyone. Can you hear me?
Yes, I can hear you. Go ahead.
Okay, thanks. My name is Hiếu. I come from Vietnam and currently working at Big Star Vietnam and a graduate student at Hanoi University of Science and Technology. So in this presentation, I will introduce a new practical problem in machine learning named extractive task summarization. And our proposed solution to deal with this problem using deep learning. And here is the agenda. The presentation will have 4 sections. First, I will introduce an extractive task summarization problem, or you can say ETS for short. Next is the main part of the presentation, our proposed solution to deal with ETS problem. Then we will have a short discussion about the future work. And finally, let's wrap everything up. Okay. Now let's begin. So why do we have the name extractive task summarization? I have worked for stock photo company as a research intern. This company runs a business that helps photographers and artists sell their works of art. For convenience, I will call these people by the term contributors. Basically, the contributors upload their images to the system along with corresponding tags they choose to annotate, or you can say to describe their images. The tags will then be used by the search engine to help customers find the relevant images for them. The problem arises when the number of tags used to describe an image is high. Hundreds or maybe thousands of tags are assigned to an image. So the search engine will face a big challenge. To help the search engine, we could try to reduce the number of tags with a machine. And can you next slide for me? Thanks. And here is why the name extractive task summarization comes from. The goal of extractive task summarization task is to shorten the list of tasks corresponding to a digital image while keeping the representativity. But why extractive? Because we only choose the important tasks from the original tasks provided by the contributor, not to create a brand new set of tasks to substitute the original ones. This problem is similar to text summarization to help condense a long article on news to main points. But here, we don't work with words, but tags, and we don't care about the order of tags. Now we can move to the main part, the deep learning solution for the ETS problem. Okay, here is the whole architecture of the solution. We will have a closer look at the first half of the architecture. Okay, we take an image and a list of all corresponding tags as true inputs. All the tags will be embedded to a vector space using the embedding layer. So each tag will have a corresponding n-dimensional vectors. The image, after going through the image feature extractor, results in a list of n-dimensional vectors, each vector representing a region of that image. The image feature extractor could be anything. A CNN model like ResNet is a great choice. Can you move for me? One more slide. Okay, thanks. To fuse the visual information with the textual information from tags, we use a multi-head attention layer, which introduced in the Attention is All You Need paper by Vaswani S4. The tag feature vectors will take the role of queries. Can you make a slide for me? Okay, thanks. The tag feature vectors will take the role of queries, while the image region vectors play as the key and values. In other words, each tag vector looks at the whole grid region of the image feature maps, and the duty of attention mechanism is to guide the tag to which region should be attended. The desired output would be the fusion of image and task information. Now, let's look at the remaining part of the architecture. Can you next slide for me? Thanks. So after we have the feature vectors of tags and the fusion of tag feature vector and image region vector, we will feed these vectors to two transformer encoders to classify if task is important or not. The scoring layer here is just a simple The scoring layer here is just a simple linear transformation along with a sigmoid activation function. The model will have three outputs, two auxiliary outputs on the left and on the right. And the final one is a combination of two auxiliary outputs using the gating mechanism. Each output will be a list of floating point value in range of 0 to 1. Of course, we can define a threshold. For example, 0.1 for which task with corresponding float number higher than the threshold will be considered as important. Now, let's talk about the gating mechanism. The design of gating layer is pretty simple, composed of two linear transformation, and the output will be passed through a sigmoid activation function. The final output of the gating layer will be n floating point values in range of 0 to 1 for corresponding n tasks. So for a single task, we will have a floating point value that comes from the gating layer. For instance, I will denote the output number 1 as O subscript 1, output number 2 as O subscript 2, and the output of gating layer will be G. The final output will be O subscript 1 multiply G plus O subscript 2 multiply 1 minus G. In the training phase, we will have three loss functions for all three outputs. So some of you might ask, why do we have three outputs? As you can see, you can imagine that we are having two experts here. One on the right using task feature vector to predict which tasks are important. And one on the left use the fusion of task feature vectors and image region vector, while two experts try their best to learn the classification rule with two auxiliary loss function. The gating layer will fuse the output of two experts to make the final decision on which task should be marked as important. Interestingly, this is similar to the manually labeling process, where one labeler might first look at the list of all tasks to spot the might be important tasks based on the surrounding tasks and the task as well. Then he or she can use an image as a reference, try to find the relevant objects, concepts in that image, and use all the information he knows to design the important tasks of that image. Back to the deep learning solution, with this architecture design, we name this model multi-auxiliary with gating network, or Magneto for short. That's enough for the architecture of Magneto apropos solution. Now let's move to the discussion. So the gating mechanism presented in this work is just our first attempt to fuse the outputs of two streams or two experts. We have not performed any hyperparameter tuning for this specific layer, and even have not decided which are the best input features for it. Therefore, Magneto architecture definitely could be further improved just by leveraging a better gating mechanism. Another aspect that can improve the model performance is by preventing the imbalance among the concepts frequencies. And the last thing that should be paid attention to in the future works is a mapping mechanism from the task feature vector space to the image one, or we can say the fusion between task and image region. So in this presentation, I have introduced the extractive taxonization problems, present our proposed solution, multi-auxiliary with gating network, how we use the visual and textual information to deal with extractive taxonization problems, and having a few words about some direction for the future work. So thanks for listening.
Thank you for the presentation and for the idea. We are sorry for technicalities that always happens, but at the end of the day, we are lucky enough to be part of the presentation. And so it's over to you, Doctor, for the question.
Yeah, this huge. I have a very this you is your pronunciation. You. This my question is because you are giving only the concept of that, but you are not implemented it now till, right? You are not implemented.
Sorry, can you ask again?
Have you implemented it?
Yes, I already have the source code to run the whole architecture with
Okay.
the
Okay. Okay. Then my question is, how many epochs are you have used in this case?
It depends on how big the data is. We have a big a data set, very big, with about 3 million items, and it takes about 50 epochs to have a model to fit with this data.
Okay. What do you think about the overfitting of the model?
Sorry, can you ask again?
What do you think about overfitting of the model?
Of course, the model can overfitting, but we have used some scheduler to prevent this phenomenon. For example, we can reduce the learning rate over time, and it can prevent overfitting very well.
Okay. Now, thank you. Thank you. Thank you. Thank you.
Thank you for the presentation, and thank you, Doctor, for the feedback and ideas, which will for sure extend the work and get it to another level and another contribution in this important field. Thank you, everyone, for the great presentations and the contributions that you are presenting to the knowledge. Unfortunately, we missed two presenters, thus we are moving now to the closing of this session, but for sure you are welcome to join the next sessions in case that you are interested to participate, to ask questions, or to listen to the ideas in your field. So I sincerely thank you our authors for the excellent presentation and contribution again, and for all presentation in this international conference. And I hope the session was informative and reflective enough to your area. All of your work is appreciated, and for sure that you will get your digital certification within a couple of business days. Furthermore, we are already forwarded the publication for Springer for publication purposes. It took usually 5 to 6 months, so kindly cooperate, keep an eye on the emails that we will
Your voice is not coming. Feroz, your voice is not coming. Okay, I think Feroz is disconnected. Yes, Prathna Joshi. Yes, please. I think your voice is not there. Prathama, your voice is on. Please unmute yourself. Please unmute.
Yeah, I'm really sorry.
Hello.
I lost the connection.
Yeah.
I lost the connection. I'm really sorry. I'm really sorry for that. So again, on behalf of ICICT 2022 and Global Knowledge Research Foundation, we highly appreciate and thank your efforts. Thank you for your valuable time. At the end of the session, we can even take a screenshot as an evidence that we participated in this day, even it's virtual.
Right,
so
right.
I would appreciate if you can open your cameras, turn them on, so we can celebrate this success and this memory. So thank you, everyone. I will count 3, 2, 1. Okay, thank you all,
Thank you.
and hopefully to see you soon. Thank you, Dr. Agil. Thank you.
Thank you to
Bye-bye.
all.
Bye-bye.
Thank
See you
you.
in the next session.
Thank you.
Thank you.
Thanks.
everyone.
Okay, thank you. Should I leave?
Yes,
Yes,
we
sir.
can.
Yes, sir,
Okay,
you can.
thank
Thank you.
you. Thank you.